So we're going to use the Lego TIE Fighter. I have a TIE Fighter, and it's moving through space, and it's got a big net on it, and I'm trying to catch meteors. And he moves in straight lines at constant velocities, and I want to know, depending on what straight line he follows, how many meteor bits he catches. And I want this to be independent of logic or like if statements in the program. I want it to be, I feed it a map of the density of meteorites in different locations, and it will tell me for any given path how many meteorites he will catch. I'm going to draw out a meteorite map for us. So we can have a map here for every unit of time and distance. Since he's moving at a constant velocity, we'll just have them equal. So it moves 1 unit of distance per unit of time. And here he'll catch 3 meteorites, and here he'll catch half a meteorite, like maybe tons of meteorites. So 3 tons, half a ton of meteorites, and 1 ton of meteorites. If we had him moving in a simple line, so we can see here, path 1, literally just the distance times 1 ton of meteorites, that's how many he would catch. If we say the one where he's fully in the region where he's catching 3 tons of meteorites per unit distance, distance times 3. What if we have a terrible path? We got path 3. He starts getting 3 tons per unit distance to 1 ton to half a ton and back to 1 ton. So clearly we can't just take a distance function there and multiply it by a constant because they're different all across the board. And remember, I want to be able to give it any path and any map of meteorite density and figure it out. So we start with, they're called sigmoid functions. That's not important. What's important here is that we have a 3D representation of our meteorite map. So this is a different one, right? You can see that there's 0 meteorites all around here, and then we have the circle and the square, which has a density of 1 tons of meteorite per unit distance. If I have a path, maybe from here somewhere to here, you can see that some of it is spent inside the circle and some of it is spent here in the meteoriteless wasteland. And what we can do is we can actually take the line integral of here to here of this map function. And if we were to draw that out, say, this is A and this is B, and the meteorite density as we go along, we'll start at 0 because we start outside in the meteoriteless plane. It'll jump up to, in this case, it's 1 because we're in the meteorite dense circle. And then we'll jump back down to 0 and continue till we get to B over here. And now the cool thing is now that we have this shape, we can just take the area underneath the curve, and that's how many tons of meteorite we get, because it's the density of the meteorite field times how far we travel within it, and that gives us how many meteorites we collect. But then say if we continued here and entered the square and collected more, and then left the square and collected 0 again to get to point C, then we can add all this in, and it can be a different density, and it can have a different length, and it doesn't matter because we're taking the integral of the straight line from A to C. Given a mathematical map like this, we will know how many meteorites it collects. And I think this is a super cool thing that I'm sure has been figured out before, but I figured it out, so I feel proud of it. It's just a way that instead of having to program like, if the particle is in this region, calculate this distance with this constant, you know? Instead, I can just say, here's the map that I designed beforehand, calculate it with an integral for me. Essentially, I'm taking what could be a programming challenge and turning it into a mathematics challenge, so that way I don't have to program it, and that just makes it easier for me to change things up, because now I just changed the map instead of saying, now I have to figure out different boundaries. Anyways, before I go, I gotta thank the Bazills. They got us these shirts. I know you have a matching one that's in navy, but they're super cool, and I try and wear them from time to time, and it's also entertaining, and it's the same red as my red dress shirt that also matches all of my Wisconsin Badgers gear, so that's really cool. Anyways, NFC Championship this weekend, so go Pack Go, and I'll see you on Monday.